Hello, everyone, and welcome to this episode of the podcast. We've got a special guest here. I'm joined by Robyn Chuter, who's a certified lifestyle medicine practitioner. Welcome.
Thanks for having me on.
Fantastic. Robyn is a very well researched medicine practitioner, and basically what I want to talk to Robyn about today is the gut microbiome. And we're going to talk a lot, and we're going to go into detail about some of the research that's been published around the microbiome. What's the best solution to make sure that you optimize your microbiome as best as you can, and also just discuss some of the myths around fiber and dealing with people who've got inflammatory conditions and how to optimize things. Probiotics, we can talk about those a little bit as well. And so yeah, again, welcome to the podcast, Robyn. And first of all, what would be some of the main things that when you want to just start talking about the microbiome on, I guess, like a macro level before we go into the micro side of things? What would be the first kind of things that you'd like to make the audience aware of around the best things to do initially to if you've got some form of dysbiosis, or you're interested in learning more about the gut and the trillions of bugs that are in there? What would be some of the things that you'd like to share around that information?
Wow. Okay. Such a huge topic, but
Yes,
I guess
I
starting at that real kind of 60,000 foot view, there is an ongoing project called the American Gut Project, and it doesn't just involve Americans. People from all over the world can participate in this. And what the American Gut Project has been doing is collecting samples of people's gut microbiota. I'll leave it up to your imagination how those samples are collected. We don't need to go into that in case anyone's, eating right now. But anyway, so they get samples from people, and they carry out an analysis of those samples to find out essentially what is the composition of that person's fecal microbiome, which is perhaps not exactly the same as the gut microbiome, but it's about as close as we can get with current technology. So people send in their samples and they get analyzed genetically. When people send in their samples, they also have to fill in and send back a whole range of questionnaires. And these are really detailed. So some of the questions would be things like, when was the last time you had antibiotics, and do you exercise, and do you exercise indoors or outdoors, and were you breastfed, were you born through cesarean section, all this sort of thing. And they also send in dietary questionnaires. And again, these are reasonably detailed. And then using the miracle of big data, where you can take all these kind of ridiculously large numbers of points of information and then just crunch them using some mind-boggling algorithm. And what they can then produces correlations. Now, correlation doesn't equal causation, but what they were looking for specifically is what diet and or lifestyle factors show the strongest correlation with a healthy, which means diverse, gut microbiota. And out of all those data points that they collected from people and synthesized, there was one that was the strongest correlation with a healthy gut microbiota, and that was diversity of whole plant foods. So specifically, people who ate 30 or more different whole plant foods per week had the healthiest and most diverse gut microbiota. And that's really the take-home point, because as you know, there has been such a proliferation of books and articles and podcasts and blogs and whatever the heck else on gut health. It's like the topic du jour, the topic of the year, the topic of the decade even. And the ideas on how to cultivate a healthy gut microbiome are all over the map. And so we've got people saying you should go carnivore, and other people saying you should drink kombucha, and other people saying you shouldn't eat wheat, and blah 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 blah. And actually none of that is true.
Yep.
Eat plants, a good variety of whole plant foods, 30 or more in a week, which is actually not really that hard if you think, well, Well, okay, so this is how I explain it to my clients, right? When they're going 30 in a week, I go, well,
Yeah.
okay, what are the categories of plant foods? You got fruits, you got vegetables, you got whole grains, you got legumes, and you've got nuts and seeds, and you've got herbs and spices.
And
That's 6
actually, and
categories.
herbs and spices play a role in each of those 30. So, you know, you could add 3 or 4 herbs and spices to a meal. There's 3 or 4 new plants that you never had in the, you know, in your diet.
Absolutely.
And that counts, you know, and people don't
Yeah,
realize that, you
it
know?
does.
Yeah.
It
Yeah.
does. So for dinner last night, we had a dal, and of course, when you make dal, you can put all manner of spices in. So I think
Oh, yeah.
I
I know
probably
all
had
about
about
Dal,
8
Robyn.
spices. Of course you do. So I had about 8 spices in the dal.
Yeah.
Could have
Yeah.
been more. Probably
Mm.
was more like 10.
And a lot of people put different types of legumes in dal as well. So you can put 4 or 5 different legumes in a dal. You can put different, you know, 10 different
Different vegetables.
vegetables in a dal. You could have
Yeah.
20 or 30 different plants in one dal if
And
you
then, and
really.
then if you wanted to have your dal, say, with rice, well,
There you
you
go.
could do a mixture of brown, black, and red rice, okay? Because
Yes.
each of
Yeah.
those do count as a
Mm.
different plant,
Yeah.
because what makes difference in the plant world is
Mm.
the different composition of things like polyphenols, which are these
Yes.
pigments. That's
Yes.
what makes your red rice red and your black rice black and your eggplant skin purple and
Yep.
yada yada. These are
Yep.
polyphenols, and so even though rice is rice, black rice is actually different from a gut microbiome point of view than brown rice, and red rice is different again. So you could, in theory, get all your 30 different foods
One
just
go.
with one meal.
Yeah.
You
And
really could.
if you had a salad, there's another like 5 or 6 different things next to that on top of it,
That's
you know?
exactly right. That's exactly, or you have some condiments with your dal. So you
Yes.
do your,
Yes.
your little tomato onion salad,
That's right.
and you
Yep.
could do a banana and coconut sambal,
Yeah.
and yeah,
Yeah.
you could hit 30 in the one
Mm.
meal.
Mm.
So it's actually not that difficult to achieve the kind of dietary diversity that was
Mm.
found in this American Gut Project.
Mm.
By the way, I mentioned you don't have to be American. The majority of people who send in samples are American, but they were
Mm.
collecting samples from people all over the world.
Mm.
And the same findings held every single time. So that's my broad overview for what do you need to know about cultivating a healthy gut microbiome. Eat more plants. Yeah.
Yeah. I mean, that just keeps coming up again and again, and all the research. You know, people that eat more plants, they do better. And I guess, yeah, from a really high level overview, if you really want to, you know, if you're watching this or you're listening to this, and you know, you really want to understand how to improve your gut microbiome, as Robyn said, you just need to eat at least 30. And the more you eat, the better it gets. You know, at least 30 different plant foods a week. And as we said to you, you can do it in one meal. So it's not necessarily really difficult, because I mean, if you haven't come from a place where you've been eating a lot of plants, then obviously, yes, it can be a bit overwhelming. But if you actually drill down into it and just say, okay, how can I make these ingredients interesting? Look at different recipes. And before you know it, you can be well into 40, 50 a week without really trying that hard.
Absolutely. Absolutely. I get clients to actually do this, and many of them, once they really begin focusing on this, they will very quickly realize that they can easily hit 40, 50, 60 or more in a week. Yeah. So that's really the first kind of high level overview.
Yeah.
So that's really, what should we include for a
That's
healthy
right.
and diverse gut
Yeah.
microbiome? And then the other thing I'd say from a high level is what should we exclude? And there are many, many prescription and over-the-counter drugs, for that matter, that have really adverse effects on the gut microbiota. Now, the first one that people kind of think of is antibiotics. They're the obvious one. And yeah, antibiotics do contribute significantly to dysbiosis. So, just 5 days on a broad spectrum antibiotic, the sort of thing you might get prescribed if you go to the doctor with a sore throat, or your kid has an ear infection, for instance. 5 days on one of these reduces the total count of gut microbiota microbes by about 30%.
Wow.
Which is very dramatic. Now, within around 30 days of finishing that course of antibiotics, the total number of gut microbes will have bounced back to pretty much the original. But here's the rub. the composition changes. The
Mm.
composition of gut microbes changes after
Mm.
antibiotics. The type of gut microbe that is most able to survive antibiotics, because there are certain bacteria that have a greater capacity to generate antibiotic resistance.
Mm-hmm.
Okay. This is the Bacteroides class of bacteria. So they very quickly develop antibiotic resistance. And so they're the ones that bounce back. And so
Well, how about we just go through the different classes, because most people won't understand what a Bacteroides is or a Prevotella type of.
yeah.
So
Well,
while we're here, why don't we just talk about that quickly?
Yeah. Okay. So there's a whole range of sort of levels of classification of bacteria, and so staying at that level that I'm talking about now, probably the major distinction would be between Bacteroides and Prevotella. So these are sort of two broad, you might say, families, like big groupings of bacterial species that fall into this category, be the Bacteroides or Prevotella. And on the Western diet, or like in people who eat a typical Western diet, the Bacteroides to Prevotella ratio is higher. So more Bacteroides, less Prevotella. In people who eat a more sort of high fiber, say like a traditional African diet, where animal products are eaten as a condiment, the fiber intake is off the charts, and they have a higher percentage of Prevotella. Bacteroides thrives on a diet that is higher in protein and fat. Prevotella thrives on a diet that is higher in carbohydrates, specifically fiber and fiber-like carbohydrates. So the Bacteroides aren't bad. So the types of bacteria that fall into this classification, they're not bad. They're what's called pathobionts, which means that in sort of in appropriate percentages or appropriate proportions, let's say, in the gut microbiota, they're really handy. They make some that they participate in digestion, and they make some nutrients for us, and yeah, they're pretty good. But post antibiotics, the Bacteroides population, as I mentioned, bounces back faster, and so you get this higher proportion of Bacteroides post antibiotics, and so they start to dominate the Prevotella. And unfortunately, in these sort of excessive proportions, Bacteroides creates a more inflammatory environment within the gut and also contributes to insulin resistance. Okay. So the more courses of antibiotics people have, the more their microbiome will shift toward this more Bacteroides dominated environment with less Prevotella. Okay. And so this overall pattern has been associated with a higher risk of the types of diseases that we see are really, really common in Western population. So metabolic diseases like diabetes, and also cardiovascular disease, and then your area of interest, which is autoimmune disease and autoinflammatory diseases of the bowel.
Yeah, absolutely. And yeah, so, I think it's very important to, really understand when to take antibiotics and when not to, and really be well informed around, because I see a lot of people, they're given antibiotics on a preventative basis. Oh, you've had some procedure done and now you've got to take this antibiotic just because. And that's kind of, again, yeah, okay, you may prevent something, but it may never have happened in the first place. But now you've obviously affected the microbiome, and it takes a lot of work to bring that back.
Right. There's a time and a place to use antibiotics. There are certain conditions where, for example, if a pregnant woman develops a urinary tract infection, although it's regrettable, she really ought to take antibiotics. Whereas if a non-pregnant woman develops a urinary tract infection, she can actually manage it at home just with water and Uril and this is actually recommended by the NICE guidelines in the UK. Now I've forgotten what the acronym NICE stands for, but it's kind of like the committee that sets the recommendations for doctors to follow. And they say, you can get an antibiotic prescription from your doctor, but not fill it. not stop taking them. Unless after a couple of days of just simple home management, your UTI is still there or it's getting worse, right?
Yeah.
So in the case of, say, middle ear infections, which would be the most common, probably the most common reason why kids get prescribed antibiotics. And I'll come back to why kids taking antibiotics is a really super bad idea. Again, you know, in the vast majority of cases, there's no benefit to giving your child antibiotics for a middle ear infection. For starters, most of them are viral anyway. They're a complication of a common cold. For seconds, the most that you're going to get by giving your kid antibiotics when they have a middle ear infection is about a half a day's less pain. Half a day, right? And there are other, you know, helpful ways to relieve pain from a middle ear infection. So, okay, why is it so bad if kids get antibiotics, particularly before the age of 3? Well, when we're born, our gut microbiota is almost non-existent. There's a few bugs in there, but not many. The infant microbiota gets its first kind of seeding dose as the baby comes down the birth canal, hopefully, assuming it's not a cesarean birth. And so the baby gets kind of inoculated with the mother's vaginal flora, which, by the way, changes significantly in the final trimester of pregnancy. So there are significant changes that occur in the normal vaginal microbiota of a pregnant woman, such that her vaginal microbiota actually start to resemble the gut microbiota just in that final leg of pregnancy.
Isn't that fascinating?
It's even been proposed, and there is some evidence to support this, that the vaginal microbiota and or the gut microbiota may play a role in signaling the timing of birth. So in other words, when a woman actually goes into labor, that may be at least influenced, if not just outright started, by signals that are sent by the microbiota. So anyway, the baby comes down the birth canal, gets a mouthful of mum's vaginal microbiota, swallows it down. That's the initial colony of the gut microbiota. And then again, hopefully the baby breastfeeds. There's actually a breast milk microbiome. There are bacteria in breast milk itself, which are sampled from the mother's gut and delivered by special white blood cells to the milk ducts. I mean, no one even knows how this happens. It's the most extraordinary thing.
The body is just
and then,
incredible.
And there's so much that we just don't understand. We can look at it and marvel, right? And then of course the baby's also getting some microbes from mum's skin when the baby's breastfeeding. So that all happens now. But the infant gut microbiota is not terribly diverse at all. By about the age of 3, the microbiota of a child is pretty much adult in composition. But those first 3 years of life are really critical. So taking antibiotics or having your child take antibiotics, I should say, in the first 3 years of life has a much more catastrophic impact on the development of their gut microbiota than taking antibiotics later in life. So we really want to avoid the unnecessary use of antibiotics at all stages of life, but particularly in the first 3 years of life. And you know, when your child is sick and the doctor wants to prescribe antibiotics, like, just slow them down and say, okay, what would happen if my child didn't take these antibiotics, or you know, if I try to manage this without antibiotics, what are the things I should look out for that would be signs that I should start my child on the antibiotics, right? So these are very valid questions to ask. And obviously, as I say, there are certain circumstances where antibiotics are absolutely life-saving and should be taken. But that's not the majority of cases in which they're prescribed. Aside from antibiotics, there was actually a study that was done. It was published in 2018. So I made some notes before we started talking because there's a lot of numbers.
There's so much,
They actually, in this study, they examined the effects on the microbiome of over 1,000 drugs. These are drugs that are commonly prescribed. And they found that 24% of all of these over 1,000 drugs inhibited the growth of at least one species of bacteria that grows in that forms part of the gut microbiota. Now, they were doing this in a petri dish, right? So we don't know how this actually works inside the human gut, but that's pretty worrying. aside from antibiotics, there's the main class of drugs that they found that was just the most destructive in their impact on the gut microbiota was antipsychotics. And so this is a class of drugs that isn't just prescribed to people with psychoses like schizophrenia. They're actually prescribed a lot to elderly people in nursing homes to sedate them.
Mm-hmm.
And they're even prescribed to children who have what has been diagnosed as ADHD. And I have a number of clients who were prescribed antipsychotics, having never had a psychotic episode, but their depression wasn't being fixed by regular antidepressants. So the psychiatrist actually added an antipsychotic. Okay, so these drugs are in really, really common use. And it's been known for decades that antipsychotics really impair insulin sensitivity and therefore increase the risk of metabolic syndrome and diabetes. And it's probable that those harmful effects are mediated by the gut microbiota. So the antipsychotics affect the gut microbiota, and then the gut microbiota causes the person to be less insulin sensitive and therefore prone to developing insulin resistance, type 2 diabetes, metabolic syndrome. Okay. Any kind of hormonal preparation, so the oral contraceptive pill, for instance, and an HRT, these also have really, really significant impacts on the gut microbiota. Again, just a couple of sort of numbers here. Women taking the oral contraceptive pill have 3 times the risk of Crohn's disease, 3 times higher risk of developing. And those who've used it in the past but no longer use it have a 40% higher risk of developing Crohn's disease than women who never, ever use the pill. And 71% increase in ulcerative colitis in postmenopausal women who are taking HRT. Wow. Okay. So these drugs are in such common use. HRT, not as much as it used to be.
That used to be very common, didn't it, HRT?
Very common. Yeah. Just about all postmenopausal, well, maybe not most, but a heck of a lot of postmenopausal women will put on HRT. Yeah. So that's been tamped down, which is great. But all these women and girls, girls are often taking the oral contraceptive pill from almost the time that they first get their periods. Yeah. And doctors are writing prescriptions for...
It's handed out like candy almost. Yeah.
Absolutely. Very few of them, in my experience, talking with clients anyway, very few of them do a proper review to really assess risk for individual women in taking the pill, particularly as it relates to thromboembolic disorders like stroke. That are much more common in women taking the pill. So you've got all those kind of risks of the pill that have been known for a long period of time. And now we've got this emerging body of research on the effects of the oral contraceptive pill and HRT on the gut microbiota. Okay. So you, in your intro, you mentioned the, or was it what we were talking about before you hit record? I can't recall, but I know one of the things you wanted to talk about today was the effect of the gut microbiota on mental health, on mood and anxiety. And once again, use of the oral contraceptive pill has been found to really quite dramatically increase the prevalence of both anxiety and depression in women. And the younger a girl is when she starts taking the pill, the higher the risk that she'll actually develop anxiety and or depression. And once again, I mean, there are a lot of mechanisms by which this could be acting, but one of them quite likely is the impact of the pill on the gut microbiota.
Fascinating. Yeah.
So the do's are eat your plants, and the don'ts are, well, let's just put it this way. Really take a good hard look at any medications that you are taking or that you've been suggested to take, and are there other better ways of handling whatever ails you than taking those drugs?
Absolutely. So, we've really looked in on what can create a really beneficial kind of bacterial composition in our bowel. But, and you say, the don'ts, we talked about some of the pharmaceutical don'ts that we should be looking at. But there's a other big class of don'ts that are just straight away comes to mind, and that's the food that we eat, and obviously, which can really, really affect the way your microbiome is composed. And so let's just talk about that. Obviously, we know that anything that comes from an animal does not contain any fiber, and we start to feed the kind of bugs that we don't really want in there. So let's just touch on the don'ts around diet that can affect the composition of bile. And then we know obviously the byproducts of that. We've got hydrogen sulfide production, trimethylamine oxide production, all these kind of things that happen. Maybe we'll just touch on that a little bit as well with the dysbiosis with diet.
Absolutely. Yeah. So I mentioned before this sort of, I suppose, general divergence between the Western gut microbiota and the gut microbiota that you find in people eating a more, let's just say, traditional, or I would say evolutionary diet. And that is something I want to highlight from the get-go, is that the diet that humans evolved on was a diet that was ridiculously high in fiber. And how do we know this? Because of the study of what are called coproliths, or paleo poop. So there are fossilized turds that managed to get preserved, and there are scientists who study fossilized feces. And good luck to them, because there's a little niche in science for everyone who's got like weird topics of interest. And so from analyzing the composition of fossilized human poop, it's very, very evident that our primitive ancestors were eating much more fiber than we currently eat. Estimates are somewhere in the range of 100 to 150 grams of fiber per day.
That's huge amount.
As you know, the average person, eating a Western diet is flat out getting 20 grams a day.
Sometimes not even that.
Yeah, that's right. Like that would be a person who sort
doing
of
pretty
didn't
well.
throw the lettuce off their big mat. There's plenty of people eating a lot less than that, which explains some of the stories we hear about the infrequency of people's bowel movements. And apparently there are some people out there who think that only passing a bowel movement once a week is normal. And it is not. So
interesting story. I was talking to a client. This must have been a couple of years ago, but their doctor told them that it doesn't matter what your frequency is as long as you're regular. And regular to this person, was once every 3 weeks. And the doctor said that was completely okay.
Yep. It's mind-boggling, isn't it? I don't even know what to say about a person with medical training who thinks that it's normal to poop once every 3 weeks, because folks, that ain't normal. So yeah, our ancestors were not pooping once every 3 weeks. I reckon they would have gone about 3 times a day.
Yeah, with ease. Yep.
And just passing these very, very large bowel motions. And so why does that matter? Well, because our physiology evolved in conjunction with our food supply, as is true for all animal species. Animals end up adapting to the food supply that's available, and humans are no exception to that rule. So we, somewhere in the dim, dark mist of our evolutionary history, primitive, like the precursors of humans, essentially outsourced a big chunk of carbohydrate digestion to gut bacteria. So we, like the human part of our digestive tract, the small intestine, with all of its digestive enzymes and its bile and its pancreatic juice and whatever the heck else, we carry out most of the digestion of proteins that we eat. There's a little bacterial fermentation of proteins in the colon, but we sort of do most of that for ourselves. And we break down fats for ourselves as well in the small intestine. But there's a lot of different types of carbohydrate that actually escape digestion in the small intestine, because humans don't have the enzymes for them. We've got 27 different carbohydrate digesting enzymes that our genome codes for. And our bacterial genome, our microbial genome, codes for something in the order of 60,000 different enzymes to break down carbohydrates. Yeah. So it was a smart decision, really, from the point of view of the human genome could be kept really quite small and complex. There's only 23,000 odd genes in the human genome, which is pretty small. Rice plants have 44,000 genes in their genome. And there's a species of roundworm that's studied a lot in genetics, and it's got I think it's about 15,000 genes. So in other words, our genome's not all that much bigger than this little roundworm, which is interesting. So how then did we develop the capacity to adapt to changes in geography, changes in climate, as humans sort of dispersed out from Africa? Well, it was actually our microbial genome that gave us the adaptability to be able to move into these different habitable, or make these different areas habitable, whereas most animals have a very, very narrow range. Like you don't find polar bears outside of the Arctic, and you don't find, I don't know, like rattlesnakes have a particular geographical location that they're confined to. Humans have spread, we've spread ourselves all over the globe, and now some of us actually want to leave it, and some of us wish they would and not come back. So humans can adapt to all these different places, and that's largely because we've got this gut microbiota, which is able to adapt to change far more rapidly than we can, because humans can sort of replicate themselves roughly once every 20 years, or like that is, it takes 20 years to get to reproductive capacity. Bacteria can replicate once every 20 to 30 minutes. So they can, and when bacteria replicate, there are very often these little sort of genetic, you can call them mutations, but they're just little mistranscriptions in how the genetic code copies itself. And some of these mutations are beneficial to the bacteria's survival, and therefore more of those bacteria will replicate, and they'll come to dominate the environment that they're in. Okay, so bacteria adapt to a change in environment far more rapidly than animals like humans, and particularly those that take a long time to reach sexual maturity like humans. Therefore, humans rely on the bacterial genome to cope with environmental change, including a change in food supply. So there's our ancestors chowing down on these really, really high fiber foods, getting these amazingly diverse gut microbiota, and their microbiota are basically in service to those humans, right? They're making the most of carbohydrates that humans can't digest. These carbohydrates provide a great food supply to the bacteria. So the bacteria are thriving. They've got a lovely warm place to live, and there's always food in there, so they're happy. And then they're paying the host back by producing vitamins and producing short chain fatty acids and all this fabulous stuff. So this is what we see in a person who's eating a whole lot of plants. They've got a bunch of basically fiber and other sort of complex carbohydrate munching bacteria, like these Prevotella species, and they're down in the colon making all this fabulous stuff for their host. There's one particular substance called butyrate, which your fiber-fed gut microbiota are going to make a whole heap of. And butyrate, which is a short chain fatty acid, so it's a little short fat. It's not a really like long chain fat, like say some of the omega-3 fats are a long chain. These are just a couple of little globules or little subcomponents of fat stuck together. Butyrate actually provides for 70% of the energy needs of the human cells, the colonocytes that line the colon. So all the other cells in your body are mostly reliant, there is one exception, that's the small intestine. Most other cells in your body are really reliant on the bloodstream for providing them with their energy needs. So they've got to have access to the capillaries so they can take up glucose or fatty acids or lactate or whatever they run on, okay? But your colonocytes are running mostly on butyrate, which is made by your gut bacteria from fermenting the certain types of plant carbohydrates. So you've eaten the plants. Your human digestive tract has extracted the glucose and the starches that you need for energy. The stuff that you can't digest gets passed on down to the colon. Your bacteria ferment it and produce short-chain fatty acids, which they have no use for. They're just a byproduct of bacterial metabolism. Your colonocytes take up the short-chain fatty acids and use them as fuel. Like, it's mind-boggling.
A masterpiece, basically.
It is. It is a masterpiece. All of nature is, but like there's so many things within us where you just go, whoa, like that's pretty mind-bending. So now this butyrate, if you are taking in so many of these types of carbohydrates that the butyrate production exceeds what your colonocytes need for their energy requirements, there are actually specialized transporters in the bowel wall. So the cells of the bowel wall have these little receptors, you might say, for short-chain fatty acids, including butyrate. So they absorb the butyrate, pass it through into the bloodstream. And now you've got butyrate traveling around in your bloodstream, and it's a systemic anti-inflammatory. Because it's a very small molecule, it can even get into the brain. It can pass the blood-brain barrier, which not that many things can. So it gets into your brain. It's an anti-inflammatory in your brain. But on top of that, butyrate actually stimulates the production of something called BDNF, brain-derived neurotrophic factor. Neurologists or neuroscientists call this miracle grow for your brain. It actually causes new brain cells to grow, especially in the hippocampus, the region of the brain that has to do with like memory and emotional processing. And it causes new connections between neurons to form. Okay, that's what BDNF does. So again, you're eating all that fiber and resistant starch and, you know, oligosaccharides, the kinds of stuff you find in legumes, vegetables, and whole grains and fruits. And your gut bugs are making out of these types of carbohydrates this substance which has effects all through your body. Oh, butyrate also enhances insulin sensitivity. So it makes you less likely to, you know, develop metabolic disease, including diabetes. Butyrate can also be taken up by the cells of the small intestine and used to heal the condition known as leaky gut. So the butyrate made in the colon is then able to be taken up in the small intestine and to repair the sort of abnormally high gut permeability that causes symptoms like inflammation and food intolerance and the condition people describe as brain fog. So yeah, that's what happens on a plant-based diet. Now, what happens if you're not eating all that fiber? So your butyrate producing bacteria are well, there just aren't many of them because there isn't enough for them to eat. And instead, you're taking in a whole stack of protein and fat. So you're now going to have, again, a lot more Bacteroides and proteobacteria in your colon. And many of these bacteria are, so when you eat more protein than you need, the amino acids from the protein can't all be absorbed in the small intestine because it's just more than the body can actually physically take up. So you end up with these amino acids and even undigested proteins down in the colon. There are bacteria that carry out a fermentation process of undigested protein. It's just that in the case of protein fermentation, the term that's applied to that is putrefaction. Which is about as appealing as it sounds. And there are some dead nasty compounds that get produced from this putrefaction. There's one called putrescine. There's another one called cadaverine, as in cadavers, you know, like dead body parts. So that's why meat, that's what's in your colon. So yeah, like your putrefaction products, that's what's in your colon when you eat meat. Oh my goodness. So what do these do? Well, they're very pro-inflammatory. Then of course, when you have a high fat intake, again, the fat can't all be absorbed in the small intestine. So some of it's going to end up down in the colon, and there are certain bacterial species that will carry out processes on fat. But the other thing is that a high fat diet causes the release of more bile. So bile is an emulsifier, like a detergent. For those of you who haven't discovered the joys of oil-free cooking and are still using oil in your cooking, you'll know that when you go to wash up your pots and pans that you've used oil in, you've got to use detergent, because otherwise you can't get all the fatty stuff, all the residues off your plates and your pots and pans, right? So, because fats are not water soluble. So when you're washing up, you've got to use a detergent. Okay, so bile is like a detergent. It's made in your liver, stored in your gallbladder, and it gets squirted out into the small intestine when you eat a meal that contains some fat. And bile's very useful. It emulsifies fat in the small intestine. This allows us to take up the components of fat that we need, and also fat-soluble vitamins A, D, E, and K. That's all fine. But then that bile, some of it gets reabsorbed at the end of the small intestine. But if you've had a lot of bile release, not all of it will get reabsorbed. So now some of that bile is down in your colon. And there are bacteria that actually eat bile. Again, bacteria are highly adaptable. These bile-eating species, they're called bilophilic, lovers of bile. And one of them is called Bilophila wadsworthia. So it's a bile-eating bacteria named by a bloke called Wadsworth, because apparently blokes like to have bugs named after them. There's a whole lot of gut bugs that are named after blokes. I actually don't... I could be wrong. I'm happy if anyone's got a suggestion as to a gut bug named after a chick. They all seem to be named after blokes. I find this interesting. Why do blokes want bugs found in people's, colons named after them? Anyway, I digress. Okay, so this Bilophila wadsworthia, there's also a bunch of bacteria called Desulfur vibrio. Like that's a family of bacteria that eat bile. And you mentioned hydrogen sulfide before. So hydrogen sulfide gas is actually made by these bile-eating bacteria in the process of digesting the bile. Hydrogen sulfide, as I'm sure you know, given your major area of interest, is a contributing cause of ulcerative colitis.
Big time.
High hydrogen sulfide, or like high levels of hydrogen sulfide and high counts of the bacteria that produce them, have also been found in the bowels of people who get colorectal cancer. So, I mean, no surprise, right? This is an inflammatory substance. Yeah.
Yeah, it causes damage, causes damage to the cells.
Yes, it does. The other thing is that hydrogen sulfide gas causes the condition known as visceral hypersensitivity. So leaving the topic of inflammatory bowel disease for a sec, which is your Crohn's and ulcerative colitis, as you know, then we've got this other category of very, very, very common gut problem called IBS or irritable bowel syndrome, which is part of the part of a group of conditions called functional gastrointestinal disturbances or disorders. So there's no structural damage to the gut like you see on a colonoscopy with a person with Crohn's or UC. You see these the inside of the gut's all angry and red, and there's ulcers and there's bleeding, and it's a mess. In IBS, there's no obvious structural change, but the person is getting abdominal pain, they're getting bloating, they're getting diarrhea or constipation or both, swinging back and forth between them. And the hallmark of IBS is visceral hypersensitivity. It's like a communication breakdown between the brain and the gut brain. Okay. And this hydrogen sulfide gas actually causes or leads to this communication breakdown that results in visceral hypersensitivity. So that's what happens when you get off the diet that humans evolved on, like this really plant-rich, fiber-rich diet, and you go onto the typical Western diet, getting round figures 40% of your calories from animal products, which, as you mentioned before, quite rightly, have zero fiber. What they do have is a lot of protein and a lot of fat, some more than others. And and of course the other hallmark of the Western diet is processed food.
Oh yeah.
So carbohydrates and plant foods that have been stripped of their fiber and their phytochemicals and whatnot, and all you've got left is sugar or starch or oil. And
They're
these
also
are
filled with all sorts of things, maltodextrin, emulsifiers, all these things that are
yes,
big, I guess alarm signals.
and
You're putting those things into your
nanoparticles.
gut.
Oh my goodness! Like you're probably familiar with the research on nanoparticles and IBD. And these nanoparticles, nanoparticles of titanium, for instance, which are found in processed
Oh yeah.
that are added there for reasons of appearance primarily, because processed food looks pretty disgusting when it comes out of the extruder. So you got to add something to it, otherwise people would go, "Ooh, gross." It'd be like, have you seen the movie Soylent Green?
I haven't. No.
Oh, okay. Yeah,
Yeah.
it's very dystopian. Let's just put it that way. So in
Okay.
Soylent Green, the plebs eat this basically like just this extruded food. It looks a bit like dog kibble, but slightly bigger. So yeah, that's essentially what you're seeing in Soylent Green is pretty much what processed food is. It's just got like prettier colors, So
It reminds me of what they
then
do to salmon fish in factory farming, how they dye the color of the flesh to make it look more appealing, yeah.
because otherwise it's grey and no
It's
one wants
great,
to
yeah.
put grey salmon. It doesn't look good. So
No.
yeah, they actually have these color swatches, like when you go to
I
the
know, I've seen
hardware
them.
store to
Rosine has them. You can just say, oh, which color do I want my fish to be? Yeah, I've seen that. Yeah.
which is
It's
really, that should make people
yeah.
think about whether they ought to be eating those foods. It really should.
Absolutely.
So,
Yeah, so yeah, getting back onto those bugs. So yeah, obviously what we're doing when we're feeding the bugs that we don't want, we're increasing their populations, aren't we? And then they're the ones that start to become the dominant species in our bowel. We get dysbiosis and they cause all sorts of havoc, which then, down the line leads to our problems with the gut, whether it's IBS, whether it's IBD, or,
metabolic disease
cancer.
like diabetes,
Yeah.
heart
Yeah.
disease,
Even trimethamine oxide with heart disease and the link, this very strong link there. So, yeah,
indeed.
it's amazing.
Yes.
Amazing how
And
you don't realize that food that you're eating and the dysbiosis that you're causing with that has so many flow-on effects that probably can't even comprehend just by eating that one meal.
and even yeah, and so you mentioned there the kind of longer term consequences, like this is what happens to people when they're eating this diet day after day, week after week, month after month, year after year. But the consequences can be far more immediate than that, in
Absolutely.
that what you eat is going to be down in your colon within, say 3 or 4 hours of having eaten it. And then you've got bacteria living in your colon that actually make neurotransmitters, and also bacteria living in your colon that influence the cells within the gut that make neurotransmitters. And while the serotonin and the GABA and the noradrenaline that are made by gut bacteria and made and released by human cells in the gut don't actually cross the blood-brain barrier and enter your brain, they do affect the vagus nerve, which is like the Ethernet cable between your two brains. And so, for instance, in people who have eaten a very high-fat diet, there is an increase in endotoxin within their bloodstream within a few hours. So endotoxin is a component of the cell wall of certain types of bacteria. They're called gram-negative. So fat actually, particularly saturated fat, actually ferries endotoxin across the gut wall and into the bloodstream. And if you actually, hopefully with the person's permission, experimentally inject endotoxin into a person's bloodstream, they experience anxiety. So when people feel horrible day to day, they're feeling anxious, they've got low mood, There are many, many reasons why a person can experience anxiety and depression. Obviously, and there's a lot going on in people's lives, especially now. So I'm not saying that what you eat is the sole arbiter of how you feel, but it has a really big impact. And the research on the link between food and mood, which really only got going in earnest, I would say maybe 10 years ago, that research is really starting to pick up. And there is no doubt that when people eat a more whole food diet, they experience less anxiety and better mood. There's a lot of mechanisms for that, but one of them, once again, is the gut microbiota.
Absolutely.
So it's not just, if you keep eating this rubbish, you might get colorectal cancer in 20 years. It's when you eat that hyper processed, that ultra processed, hyper palatable Big Mac fries and a thick shake, you're actually going to be feeling pretty yuck within hours of eating that.
Yeah, absolutely. So it's short-term negative effects and long-term negative effects. I mean, yeah, and it's just I guess it's just the misinformation, disinformation around not understanding that these foods, can be so harmful to your health. And if people really understood this information, which is why we're so keen to share it, isn't it, Robyn? I mean, if people really understood what the stuff was doing to them, they wouldn't touch it. Wouldn't get anywhere near it. But they're just told,
any more than if you had a bottle marked poison sitting on your coffee table. You're not going to go, heck, I think I might have a swig of this.
No matter how good it tastes,
Yeah, that's right. That's exactly right. But as you know, the food industry is enormously profitable, and there's a great book called Salt, Sugar, Fat by Michael Moss, who is an investigative reporter. And he has a new book out called Hooked, which I must confess I haven't read yet, but I can't wait. But if you read his books, Salt, Sugar, Fat, Michael Moss actually got access to fairly high levels of a number of multinational food corporations. And so he was actually able to go to the labs where they design these foods and whatnot, and read the book. It's great. Let me just summarize. They spend wads of money getting the composition of these foods just right. They employed psychologists and food technologists. They spend unbelievable amounts of money before they ever bring a product to market, just tweaking every last aspect of that food in terms of how much salt, how much sugar, how much fat, how much of this, that, and the other do we add for the right degree of crunch, or what they call the bliss point, which is the point of sweetness where people go, wow, that's amazing, but it hasn't crossed the line into, ooh, that's kind of sickly. So these products are addictive.
Yeah.
They don't like to use that word. It's a word that they stay away from, and I guess that's why Michael Moss's book, most recent book, is called Hooked. It's pretty hard to deny. These foods are actually crafted to be addictive. So for all those people out there who are going, okay, I hear what you say, but man, I just can't give up my chips, or whenever I walk past Burger King, I just can't not go in. Yeah, I get it, right? You've been hooked. Your gut microbiota play a role in that too, just saying, right? I mean, the evidence on food cravings and gut microbes isn't as watertight as some people like to make out, but there is some evidence that who you have living in your colon contributes to what kinds of foods you enjoy and crave.
And I guess you can see that through experience, can't you? Like, you see someone who's, like I'm sure you've worked with hundreds of people like this, where, they've been hooked on junk foods and, fast foods and things like that. And as they start to change their diet after the obviously, the withdrawal period that everyone has to go through when you're addicted to something, and they start getting healthier, and they get shifts in their gut bacteria, and they start eating more fruits and vegetables and whole plant foods, they start craving more. I'll tell you, I'm a perfect example of that. you know, I used to be hooked on KFC and McDonald's and chocolates and soft drinks and all those things.
Oh,
But now the
that's
thought of eating some of
yeah.
that stuff, I don't, you know, you give me a mango, you
Yeah,
know,
I
that's
know, right?
just,
It's so funny. I was that person, like in my teens, I was
mm,
that person who, if I walked past the cheesecake shop, I'd be like, yeah, face pressed up against the glass, just going like, give me one of everything, you know. And now I look at those foods, and the Michael Pollan's phrase, edible food-like substances, springs to mind.
mm,
I look
mm,
at those things; they actually don't look like food to me anymore. And sometimes I kind of catch myself and go, oh, this is really interesting. I have those again, edible food like substances, because I don't think we should glorify them by the name food. They actually have no appeal. But let me
mm,
loose in a fruit and veg shop, and
mm,
I'm a crazy woman. I'm running around going, ooh, this looks interesting. How about we try
mm.
kohlrabi?
Absolutely. Yeah, absolutely. Now, just as we kind of finish off, I just want to touch on this one point that's been kind of publicized quite a lot in the community around the gut microbiome and things like that. And that's you know, SIBO. Okay.
Yeah.
Because I think there's a lot of misinformation around SIBO, and there's a lot of people trying to make you think that SIBO is more than what it actually is. And so, you know, why don't you just talk a little bit around what it is and what the science says about it and what we can do about it? I think that because I think there's a lot of
Yes.
noise around the SIBO thing where it's more confusing than anything it shouldn't be.
100% agree. Okay. The first thing to say is that SIBO it remains a contentious topic. And within
Mm,
the field of gastroenterology, there are gastroenterologists who I wouldn't say deny that it exists, but say that it is exceptionally rare and it really only occurs in say blind loop syndrome. So you know, people who've had, for example, surgery on their intestines for Crohn's
mm,
disease, and that other than that, it's not really a thing. And then you've got gastroenterologists who say, look, you know, somewhere anywhere up to 80% of people with IBS actually have SIBO, and these include very, very prominent gastroenterologists.
mm,
So, uh, what is the average person to make of that? Okay, SIBO, which is, for your audience, small intestinal bacterial overgrowth. So
mm,
this means both a higher number, a higher total count of bacteria in the small intestine, remembering that the colon, the large intestine, is where the bulk of our bugs live, right? So we've got, you know, 100 trillion odd bugs living in the colon. The small intestine has bacteria, but not nearly the same concentration as the colon. So the definition of SIBO is any more than 10,000 bacteria, if my memory serves me correctly. I think it's more than 10,000 bacteria per mil of fluid
mm,
in the lower part of the small intestine, the terminal ileum. So, but it's not just an overgrowth, it's actually a dysbiosis. So SIBO is a dysbiotic condition, so bad bugs growing in your small intestine and too many of them. Okay.
mm,
So SIBO does exist, and I have actually seen cases of it. There are certain conditions, for example, hypothyroidism and diabetes, and also endometriosis, that do predispose people to having an overgrowth of bacteria in their small intestine, because the mechanisms that normally help flush excess bacteria out of the gut aren't working so well in those conditions. And
mm,
then there are people who have actually suffered damage a to what's called the migrating motor complex, also known as the cleansing wave in the small intestine, because they've had a really bad bout of gastroenteritis.
mm.
Like they got Bali belly or Montezuma's revenge, or one of the weird and wonderfuls you pick up while backpacking in Southeast Asia, and they actually have an autoimmune reaction as part of their immune defense against the bacteria. Long story short, they end up with like a damaged clearance mechanism. So SIBO does exist,
Mm,
and but I think that I'm absolutely sure that it is wildly overdiagnosed.
mm,
And pretty much, you know, anyone who suffers bloating or gas or gets some loose stools will often either self-diagnose because they came across a website talking about SIBO, or they get diagnosed by practitioners with having SIBO. And they're then put on either herbal antimicrobials or antibiotics. And very often, more often than not, they're told that they need to eat a diet that is restricted in carbohydrates. So a low FODMAP diet or the biphasic diet or whatever. And this is really nonsense, because the characterization of this dysbiotic small intestine is not complete, but there have been some preliminary studies. And what they show is that the types of bacteria that overgrow in SIBO actually don't ferment or break down fiber and oligosaccharides and the other carbohydrates that are excluded in these diets, like low FODMAP and biphasic and so forth. So there is no rational reason to exclude those foods from the diet in people with SIBO, except that they may have some discomfort if they eat those foods and those foods undergo the normal process of fermentation in the colon, because they have visceral hypersensitivity. Okay. So it's not that the fermentation and the resulting gas formation from these carbohydrates is harmful. It's not. It's meant to happen. It's just that these people are hypersensitive to the normal degree of stretch and the normal muscle movement that takes place in the intestine when we eat those foods and our bugs ferment them. Okay. So does SIBO exist? Yes. Is it overdiagnosed? Yes. Is it appropriate to treat it aggressively with antibiotics or antimicrobials? I wouldn't sort of take that off the table entirely. There may be some cases where that's warranted, but on the whole, those treatments are wildly overused. Is it appropriate to treat it with a carbohydrate restricted diet? No.
Absolutely.
No.
Absolutely.
Yeah.
All right. Yep. I think that kind of covers it. Yeah, I think that's, we've talked a lot and covered a lot of ground there. I mean, obviously we haven't covered everything.
I hope we haven't overwhelmed your audience. They might want to listen.
No, I think this is exactly the kind of topic my audience or our audience would love to hear and understand more of, because, there's a huge amount of noise around it. And I think just having explained all the different aspects of it, and just talking through the stuff that we obviously know, but just to kind of make it more clear and understandable, and just share that information, because unless you go diving into the research, you're not really going to find it that easily, and you're not going to find medical professionals at this point in time sharing it readily, or being aware of it even, which is I guess even worse. But
to your point, a friend of mine who quite recently graduated from medicine in South Australia, he told me that in her medical degree, they did not even look at the gut microbiome, and it's been observed by researchers on medical curricula that it takes about 17 years for medical discoveries to actually make their way into the medical curriculum. So your doctor is actually 17 years behind the 8 ball.
Yeah, and
which is really,
but that depends on when they graduated too.
Yeah.
You know what I mean?
Absolutely.
So if they graduated 40 years ago, they're 60 years behind.
You're
unless
right.
they've kept themselves up, which unfortunately, I mean, they do a good amount of, I guess, professional development, but a lot of it isn't actually. It's
there's very little continuing medical education that focuses on nutrition and exercise and mind-body.
Yeah, it's all about drugs mostly. Most of the I guess the medical conferences are all about just this drug for this symptom,
greatest treatment, machine that goes in, whatever have you.
So
that's where the money.
They're 60 years behind on the research, and all the I guess development they've done is based on medicines rather than actually looking at root causes of what's going on. And so you're not really going to get the latest and greatest from your medical professional.
That's right.
Unless obviously there's some very good ones that are up to date, but I don't think
Oh,
it's the
yes.
vast majority.
Dr. B, Will
Oh yeah,
Bolsowitz,
isn't he good?
absolutely knocked it
Mm.
out of the park with education.
Mm.
Alan Desmond, you know, he's got a
Mm-hmm.
book out too. I can't remember the
Mm.
name of his book. You might want to put it
Mm.
in the show notes for people
Yeah,
to look
yeah,
at.
yeah.
No, it's and Zach Bush. Oh,
Mm.
legendary. Yeah.
Yeah.
So no, there are some fantastic doctors who
Mm.
have taken a really deep dive into this, and they're you know helping not just their own patients, but they're really getting it out there using the platform that being a medical doctor affords them.
Exactly.
And yeah, so people do need to take responsibility for their
Mm.
own health and not assume that their doctor knows all this stuff.
Exactly.
It is challenging to do that in the
Mm.
wild west of the internet, as you know, where there are a lot of
Mm.
people who make themselves out to be experts and they're really not. And so it's difficult for the average person to sort of
Mm.
navigate that. But
Mm.
shameless plug. As you know, I do write a weekly newsletter, and I will, if you want to put a link to my
I'll do that.
article in the show notes, you can
Mm.
actually just send people directly to the page of my article library, which has to do with everything gut related.
I'll do that.
Okay,
I'll definitely link that.
there's like 30 articles on there. So
Mm.
if you want to find out more detail about any of the things that we've discussed,
Mm-hmm.
I've written an article on it, and
Yes,
it's in that
yes, you
article
have,
library.
and it's very well researched, and you know, it's not really a shameless plug, Robyn. You do some amazing work, and Robyn is very thorough, which is why I've got her on here to discuss this with you, because she dives deep. She just doesn't look at the surface, and she will really
Yeah.
look at
And
the articles.
I put the links into all the
Of course
studies.
you do.
So
Yeah, it's
if you
all
like to
referenced.
nerd out, everything I write is
Mm.
like 50,000 hyperlinks in there. So you can
Mm.
go into
Mm.
those studies and look at it for yourself, which I
Yeah,
really recommend that people do. Because again,
absolutely.
you have to be responsible for your health and well-being,
And
and
we've
not
always said it, Shamiz and I always say it, don't just believe it because it comes from our mouth, you know, look into it is what we're saying actually, right? Look at the research, look at the evidence. Don't ever, just because someone says it, don't ever just believe them. I think that's really important for anyone who's sharing information on the internet, to make it really clear that, just because I've said it, don't just believe it because it's me.
That's it. Check it out for yourself. Go back to
Yeah,
the
and
original.
that's for anybody. That's for anybody that you see. Always make sure you double check it, check the references, check the information, and check that it makes
100%.
sense.
Yes, that's it.
Yeah, it doesn't make sense. That's really important. All right, Robyn, well, thank you so much for taking the time and sharing this information
Absolute
with
pleasure.
us.
Let's do it
It's always lovely to discuss all the different health topics with you. I think the audience will really appreciate that. And to everyone who's either listening or watching this, thanks for making it this far. I really appreciate you taking the time. And it's going to help you understand your body better. Understand what to do to help you get healthier. And we're all about trying to share as much information as we can on our platforms to help you become healthier, because that's the main thing. It's not about us, it's about you getting healthier, taking control of your health, and being responsible for it. So use the information that we've shared here with you today, and eat a lot more plants, and eat as many diverse plants as you can. Obviously, if you're suffering from digestive issues, maybe you can't quite diversify your diet straight away. So talk to someone, talk to Robyn, talk to us about how you can incorporate and what you can incorporate into your diet given your current situation. So never just jump to it to 100% if you've got some digestive problems. But if you don't,
100% agree on that. They're very uncomfortable if they suddenly ramp up their fiber intake.
Absolutely.
So,
Yeah. Don't go from 0 to hero with your fiber intake. But as I said, look, if you're listening to this and you've really found this interesting, please share it. Share it on your Facebook or your different social media aspects. Lots of people can learn from this information. And if you're listening to this on the podcast, subscribe to our podcast if you haven't done so, and so you'll get notified of all latest episodes. And if you're watching this on YouTube, hit the subscribe button, and the little bell notification icon will get you updates on all our latest uploads. also, if you have any questions, there's a comment section down below. So ask away and we'll do our best to answer. All right. Once again, Robyn, thank you so much for joining us. And for everyone watching, make sure you eat plants and lots of them. Thanks, Robyn.
Eat your plants, be well.